Today we are going to demonstrate the direct shear test for sandy soil in accordance with ASTM D3080. This video will cover the process of direct shear test for soils under consolidated drained conditions. Assemble the shear box, put the alignment screws, tighten them properly. Measure the depth of the shear box. Also measure the thickness of the porous disc. Saturate the porous disc before the test. Place one porous disc at the bottom of the shear box. Put a filter paper on top of it. Measure the weight of the shear box. Place the soil sample firmly in the shear box. Tamp the shear box with a hammer in order to compact the soil sample. Fill the soil sample in 3 layers. Compact each layer. The compaction effort depends on the required density of the soil sample. Again, measure the weight of the shear box including the filled soil in it. The difference in weight should be the weight of the used soil sample. Place the filter paper and the porous stone. Measure the remaining height of the shear box. Thus, we can measure the height of the soil sample. Place the shear box in the direct shear test machine. Then place the top portion of the shear box to close it. Fix the direct shear box with an L-shaped apparatus. Thus, the direct shear box will be in touch with the loading jack. Put distilled water around the shear box. Make sure that the soil sample is fully underwater, maintaining saturated condition. Position all dial gauges and set the readings to 0. In the software, create a file and then set the test data, loading schedule, reading schedule, and displacement rate according to ASTM standards. Start the consolidation process for the soil sample. The consolidation process will start with a given seating load. After the end of the consolidation process, remove the alignment screws. Start applying the shear load. After the test, the software will automatically generate the stress-strain curve for the shear load. Also, the vertical displacement and normal stress can be obtained from the test results. The maximum shear stress can be obtained by dividing the peak shear load by the cross-section of the soil sample. Thus, the shear strength of a given soil sample can be determined by direct shear test under consolidated drained condition.